Here we have an illustration of a separatory funnel with an organic layer of diethyl ether containing three organic compounds: benzoic acid, azabicyclooctane, which is a base, and camphor, which is neutral. Diethyl ether has a density of 0.713 grams per milliliter, and so it sits on top of the water layer as shown here, because water has an approximate density of 1 gram per milliliter. The goal of this experiment is to separate three organic compounds. First, we will separate the acid, benzoic acid in this case, from the other two compounds. In order to do this, we will add a base, such as sodium hydroxide, which will form and mix into the water layer. If the benzoic acid comes into contact with the basic solution, it will react in an acid-base reaction, giving up its acidic proton on the carboxyl group and forming its conjugate base. In order to expose the benzoic acid to the water layer, we will agitate the mixture. Do this by swirling the two solutions together in an Erlenmeyer flask and then pouring the mixed solution into the separatory funnel. Once the conjugate base of benzoic acid has been separated from the organic layer, we will want to isolate the water layer containing this compound. To do this, we will open the stopcock and allow the water layer to drain out the bottom into a beaker labeled conjugate base of acid. We will close the stopcock before the interface between the organic aqueous layer and aqueous layer passes through the stopcock. This ensures that only the water layer containing the benzoic acid is collected and that it is not contaminated with other compounds from the organic layer, which will be separated later. Next, we will isolate the organic base from the organic layer. This will be done using the same method as for isolating the acid, only instead of using sodium hydroxide, we will use an acid, such as hydrochloric acid. When mixed, the acidic protons from the HCl will undergo an acid-base reaction with the base, resulting in the formation of the conjugate acid of the base. This layer can be once again drained into a beaker labeled conjugate acid of base. The procedure can be repeated in order to remove as much base from the organic layer as possible. We now have the organic layer left containing the neutral compound. Because the interface was left in with the organic layer during the separation, the organic layer will be contaminated with water and trace amounts of our organic compounds, and so we will want to wash it with distilled water using the same method of mixing as previously described for the acid and the base. The water layer can be drained into a beaker labeled wash water. This will be discarded. Once washed, we want to remove any water left in the organic layer using a drying agent. For preliminary drying, we will first add a solution of saturated sodium chloride, mix it and drain it, ensuring that the interface does not pass through the stopcock. We will decant the original organic layer into an Erlenmeyer flask, to which we will gradually add and swirl a granular drying agent such as anhydrous sodium sulfate until drying is complete and the drying agent stops reacting. The drying agent can be filtered out by pouring the solution through a piece of cotton into a round bottom flask. We will now have our neutral compound isolated. Now we have our three solutions, each containing one of our three organic compounds, and we'll want to recover each of them from solution. The acidic compound is recovered by cooling the solution and adding high concentration acid, such as hydrochloric acid. This reverses the reaction that occurred when the sodium hydroxide was initially added, as the acidic protons from the hydrochloric acid react with the conjugate base of our organic acid, forming the original acid. If the reformation of the acid is coupled with cooling of the solution, this causes the acid to form as a precipitate. Once the solution has a pH of about 1 on litmus, the precipitate can be filtered using suction filtration, dissolved in water, and then recrystallize. The purity of the recovered crystals can be tested using TLC. The basic compound is recovered using the same method as the acid, but using sodium hydroxide rather than HCl. By the same process, the conjugate acid reacts with the hydroxide ions, forming water, and the original base forms now as a precipitate. This precipitate can be filtered out and dried but does not need to be recrystallized. The purity of the solid can be checked using TLC. The neutral compound will be separated from the organic layer by rotary evaporation. Rotary evaporation is used rather than simple distillation because it is faster as a result of it being done under reduced pressure, and the rotation of the flask increases evaporation as it spreads it out across a larger surface area. Because it runs at a lower temperature, recovering solids with low melting points is also easier, and rotary evaporation also allows for the solvent to be reused after filtration. The solid, once recovered, will have a waxy consistency and will have a strong scent like that of Vicks.